Hi there, in this video we're going to be solving this particular problem here. Now we have a function y equals line x, and it has one tangent line that passes through the point 0, 1 right here. That's not on the curve. So if we were to graph this, let's say we graphed it, and let's say we graphed y equals line x. That would look something like this. Now if this was 1, this would be right where our point is going to lie, right around here. Notice that it's not actually on the curve. So how do we find the tangent line using this point that's not on the curve? It's not the tangent line point exactly. Well, the first thing I want to do here is, we need to notice that we're going to be using the slope point formula, the y subtract y1 equals the slope m multiply then x subtract x1. We're going to be using this to solve this problem still. So now what we want to do is substitute the values we do have. So y is going to be subtract y1. We have a point of y right here of 1 equals m x, and then we do have an x point as being 0, so subtract 0. Now we need to solve for x, but we have a y variable there, and that's going to cause some problems. So we need to get rid of the y variable. Now y, as you can see up here, according to the function, y is equal to line x, and that's exactly what we want because it only involves an x variable. So we're going to substitute line x in for the y right there. So we have line x subtract 1 equals m. Now we have to get rid of the m. So m is the slope, or rather the derivative of this right here, because we're trying to find the tangent line, so the point where the tangent line would occur. So that's going to be basically the slope of this line. And we find that by taking the derivative of line of x. Now the derivative of this is going to be equal to 1 over x. The derivative of line of x is 1 over x. And that's what we're going to be putting here. So it's going to be m is now going to be equal to 1 over x. Because whatever the x value would be, that would give us the slope of the tangent line. So x subtract 0 is just going to be x. So we just kind of ignore that, let's say. And x multiply 1 over x is just going to give us 1. So I'll just cross that out actually. And now we're left with line of x, and if I add 1 to both sides, we're going to already have a 1 here, so it'll be 1 add 1, giving me a 2. So we have line x is now equal to 2. And if you use natural laws, or log laws, we know that if we do e squared, or e to whatever is over here, it's going to give us whatever value is right here inside the line. So in this case, if we do e to the 2, that will give us x, because x is what is inside of this line here. So this is essentially what x is equal to. It's equal to e squared. So now that we know what the actual x value is, we could solve it by just substituting all of the values we know. So we have y equal, or y subtract, what is y1? Well, at this point, let's just use the points of tangency that we actually know. So we're going to do, we know that y is equal to line x, right? And now we know the x value is equal to e squared. So now the y value here that we could use is going to be line of e squared. And that's going to be equal to m, or 1 over e squared, because notice the m value that we found was 1 over x, but we know x is equal to e squared. So 1 over e squared. And then it's going to be multiply x subtract the actual value of x that we found. So it's going to be e squared. And that is kind of cutting off a bit on the side. Let me just put that in. So that is the final formula. And this would give you the actual tangent line equation. It goes somewhere like this or something. Kind of connects, or somewhere around there. Mind you, another way you could have done this was, instead of using the y value right here as line e squared, what you could have done was put these values in right here, like a 1. So you could have had y subtract 1 is equal to 1 over e squared multiply x, subtracting your x value of 0, so x subtract 0. And this would have also given you the same tangent line sort of formula. So I hope you enjoyed this video. This was how you actually find the tangent line using a point that's not directly on the curve, it's not using a point that's not actually the point of, or point where the actual tangent line would meet with the actual function, in this case y equals line of x. If you have any questions, feel free to ask in the comment section below or PM me, and I'll do my best to answer them. I hope you're having a very nice day.